In this lesson, we are once again continuing a review of Math 10 Workplace. However, now we are going to review how we can find the missing angle. So if we have a right triangle and we know two of the sides, we can find a missing angle of that triangle. Once again, it is very, very important that you check that your calculator is in degree mode. If it is not, you will get all of these incorrect. So double check that it says DEG or D. So now what we want to do is we want to find the inverse of the primary trig ratios, and we find that by using technology. So we've got sine theta equals 0.4771. So you need to check the keystrokes on your calculator and see which is the correct process. You might type second sine and then the decimal, or you might be typing in the decimal and then second sine. Some calculators, it might actually be shift instead of second. So you need to know your calculator. So I want you to try it right now as we do this, and I'm going to tell you what the answer should be, and then you double check your calculator to see if you can get it to match. We're going to go to one decimal place on these, and we always write it with a degree symbol. Notice as well we dropped the sign because no longer are we dealing with sine. We actually know the angle measure. So the angle is 28.5 degrees. So pause this if you need to. Double check how your calculator works. If you cannot get it to match, check that you are in degree mode. If you know you are in degree mode and you still cannot get it to match, you should go and find a math teacher who can assist you with your calculator. Finding cos theta, exactly the same process, except this time it's going to be second cos. Maybe then you put your decimal in and hit equals, or maybe you are putting your decimal in and then second cos. Once again, the second button might be a shift on some calculators. Ultimately, your answer is theta equals 43.7 degrees. So you need to know how your calculator works so that we can solve the next few problems. So we want to use the sine ratio to determine the value of angle theta. The great thing about this is determining which trig ratio to use is no different from what we did in the previous two lessons. It's just what we are solving for is different. We always start by labeling. Across from the 90-degree angle is your hypotenuse. Here's angle theta. Across from angle theta is our opposite side, and we have then adjacent. So you want to look to see what do we know. There was no marking on the adjacent side. The hypotenuse is 12. The opposite is 7. So that is why we are told to use the sine ratio. Sine is opposite over hypotenuse. We are looking for theta, so it stays sine theta. Opposite side was 7, hypotenuse was 12. So what we now do is we do 7 divided by 12, so we are going to divide these. Always numerator divided by denominator, so you do 7 divided by 12. Go to at least 4 decimal places unless it terminates before that. And now we use our technology. This is what we just practiced. You're going to use your second sine. Whichever way your calculator is programmed, maybe you put the decimal in first, maybe you put it in second, but you're using second sine, and you're going to get your angle measure is 35.7 degrees. So let's try another one. This time we are told we are going to use the cosine ratio. So once again, let's start by labeling. Across from the 90 degree is our hypotenuse. Our angle theta was right here. Across from angle theta is the opposite side. Adjacent is the third side. Let's see what we know. There was no marking on opposite. We are told 17 is the hypotenuse. The adjacent is 11. This is why we were told to use cosine. Cosine uses adjacent over hypotenuse. We don't know the angle measure, that's what we're trying to solve for. The adjacent side is 11, the hypotenuse is 17. So once again, we divide 11 divided by 17, and you will end up with, go to at least 4 decimal places if possible, so 0.6471. Now you use your technology, you do second cos, in whichever sequence needs to be done. We end up with the angle is 49.7 degrees. So in this particular question, it's telling us to use the tangent ratio. Let's see why we are told to use the tangent ratio. Across from the 90 degree is the hypotenuse. Angle theta was in this corner. Across from angle theta is our opposite side. Adjacent is beside the angle. There is nothing on the hypotenuse. Opposite side is 5, adjacent side is 9. This is why we are using tan. Tan is opposite over adjacent. We do not know our angle measure, so we're looking for tan theta. The opposite side was 5, the adjacent side was 9. Divide 5 divided by 9. 0.5555. Use your second tan. You are going to get theta equals 29.1 degrees. So as with the previous 2 lessons, we will finish this off by a question where you have to determine which value you are going to use. So let's start by labeling the sides. Across from the 90 degree is our hypotenuse. Across from the angle is opposite. Beside the angle is adjacent. So let's see what we know. We have nothing on the opposite side. Adjacent is 7, hypotenuse is 10. So you think of your 3 trig ratios, and you will see that cosine is the only one that uses adjacent and hypotenuse. So we can find cos of the angle theta. Adjacent was 7, hypotenuse was 10. Divide 7 divided by 10, and we get 0.7. So we're not actually going to have 4 decimal places here because 7 divided by 10 is just 0.7. So now we use our second function, cos, on your calculator, and you will get an answer of 45.6 degrees. So now you are ready to go and practice some of these and see how you do on them, and then we will be able to move in to the actual Workplace 20 trigonometry, because we have now reviewed all of the skills you would have learned in Workplace 10.